question here says we should, it says find the net force on each of the charges, okay? And however, I'm going to do for two of them, then I'll leave it to do the last one, okay? Now it says we should look for the net force on charge 2, charge 1, and charge 3, okay? So I'll show you how to do it. Now, let's start with charge 2. Now come down to charge 2. Remember, take note of the fact that it said look for the net force on charge 2, okay? Now what do? You would observe that charge 2 is going to attract to charge 1. So in terms of the interaction between charge 2 and charge 1, the interaction of charge 1 on charge 2 would be that charge 2 would attract towards it, because charge 2 has a positive charge and charge 1 has a negative charge. So since they are unlike charges, the charge 2 is going to attract towards charge 1. So what I'm going to do here is I'm going to do something like this. Okay, so the force of 1 on 2 is an attraction of charge 2 to charge 1. Then again, how about between charge 2 and charge 3? Now you can see that charge 2 has a positive, charge 3 has a positive, okay? So the net force of 3 on 2 would be that charge 2 is going to repel from it because they are like charges. Remember that when charges are like charges, they repel. Okay, so what we have, you're going to have that the net force of 3 on 2 would be that 2 repels from it. Now from what you can see from here that the net force is going to be, since F1 on 2 is moving to the right, it's going to come first. It's going to be positive, so it's going to be F of force charge 1 on 2. Then since F3 on 2 is moving to the left, it's going to be negative F of 3 on 2. Okay, so what we have to just look for F. What is F1 on 2? F1 on 2 is Q1, Q2 divided by the distance from 1 to 2 squared. Okay, so what is K? K is 9 times 10 raised to the power 9. 9 times 10 raised to the power 9. Q1 is 4 times 10 raised to the power negative 6, because we are converting from microcoulombs to coulombs, okay? Then Q2 is 5 times 10 raised to the power negative 6. Now the distance from 1 to 2 is 10 cm. If we convert to meters, it's going to be 0.1 meters. Okay, so we square it. Now we can just easily apply our calculator. I can easily use our calculator here to obtain the values. Down 0.1 squared. Okay, so the calculator gives us 18 newtons. All right, so again, we're going to look for, we've done F1 on 2, let's look for F3 on 2. So what becomes F3 on 2 is going to be K Q3 Q2 over the distance from 3 to 2 squared. So we apply our values again. K is 9 times 10 raised to the power 9. Q3 is 12 times 10 raised to the power negative 6. Then Q2 is 5 times 10 raised to the power negative 6. Well, divided by the distance from 3 to 2. From 3 to 2 is 40 cm, and that will be 0.4 meters. So we square it. Now what we're going to have here, we can use the calculator again. I'm going to have 3.375, okay, newtons. All right, so our net force therefore is going to be F12 is 18 minus F32 is 3.375. Now we can do the subtraction here. We're going to get 14.625. Okay, now 14.625, you can see that it is positive, which simply tells us that it is to the right. Okay. Now, if it is positive to the right, what it simply tells us here is that it is attracting into the system. So it's once there is an attraction, a movement to a charge, once the net force is showing a direction that points towards a charge in the system, it is attractive. Okay, so this is attractive. You can say to the right. You can either use to the right or you could say attractive. Okay, we use to the right here. So the right means it's moving like this, which means it's moving to a charge. And when it moves, when the net force points to a charge, always note that it's attractive. All right, the next one, let's talk about the net force on Q1. That is what we have here on Q1. Let's see what happens on Q1. On Q1, okay, what is 3? What's the interaction of 3 on 1? That would be attractive. Okay, so Q1, since we are looking for want to look for the net force on Q1. There's going to be an attraction of Q1 to Q3 here. Okay, so F3 on 1 is attracting. Okay, it's moving like this. Then again, between these two, 2 on 1, one is still attract because negative positive, so there's still going to be an attraction here. So this is F2 on 1 is an attraction of 1 to 2. Okay, so it means that our net force, the net force experienced by Q1 is going to be F3 on 1 subtract F2 on 1. F3 on 1 subtract F2 on 1, because if you observe very well, you can see that F3 on 1 is moving to the right and F2 on 1 is moving to the left. Okay, so I think we have F with F between 1 and 2. Now we need to look for F between 3 and 1. So what is F between 3 and 1? F between 3 and 1 should be K Q3 Q1 over the distance from 3 to 1 squared. So our K is 9 times 10 raised per 9. Our Q3 is 12 times 10 raised per negative 6. Our Q1 is 4 times 10 raised per negative 6 divided by the distance from 3 to 1, between 3 and 1 is 30 cm, which will give us 0.3, okay, 3.3 squared. So what is my F3 on 1? What would it be? It's going to be this was 4.8. So the net force therefore is going to be F3 on 1 is 4.8. F2 on 1, we've done that before. That gave us 18. So this should actually give us 13.2. So it becomes negative 13.2. Okay, newtons. Now what does that mean? It is negative 13.2 newtons to the left. It's moving like this. Okay, so this is like saying it is 13.2 newtons to the left. However, you have to now observe, check if the movement to the left is towards a charge. Let's see. So from here, if it's moving to the left, it is still towards a charge Q2. Once it's moving towards a charge Q2, okay, once the net force moves towards a charge, it means that what we have is attractive. So this 13.2 newtons is still going to be an attractive force, okay? It's still going to be an attractive force. All right. So let's do the last one. The last one is what will be the net force on Q3. Okay, let's do that. What will be the net force on Q3? So when I come down to Q3, the net force of Q1 on Q3 would make Q3 attract towards it. So the force between 1 on 3 is attraction of Q3 to Q1. Then again, if you observe between Q3 and Q2, positive charge, Q3 will repair. So it's going to move like this, okay? So this is F of 2 on 3, all right? Now, let's see what happens here. What becomes the net force from what what becomes the net force? This is the second net force on Q2. This is net force on Q1. Okay, we're doing net force on Q3 now for the third charge. So that will be, for my analysis here, is going to be F2 on 3, okay, minus F1 on 3. Okay, now this is really easy for us because we've gotten F2 on 3 before. F between charge 3 and 2 is 3.375. Then the force between charge 1 and charge 3 is 4.8. Okay, so if we subtract these two guys here, we're going to have, this gives us negative 1.425. Okay, negative 1.425 here simply means 1.425 to the left. Okay, now when you check, you can check and see that to the left is actually towards the charge. Okay, and I told you that once the net force direction is towards the charge, it is an attractive force. All right,